So today I'm going to talk about a series of SolidWorks miscellaneous tools. They're just a bunch of tools that I couldn't fit inside the demos up to this point, but they're still really useful tools. Tools I've used over 10 years of design that have really saved me a lot of time, and being the last lecture, I wanted to go over these before the semester's over. So I'm going to go ahead and discuss each of these tools. They're broken down by category, so some are relevant to the interface, sketching, editing, and things like that. So I'm just going to take it one step at a time and go over these tips. Alright, so what I have here is a spark plug, and I'm going to go ahead and go through each of these tips. Alright, the first one is the search box. I've already gone over this, but this box here, if you set it to commands, you can look up any tool you want. Okay, so you don't have to go through any of the menus. And again, I can't reiterate how important this is. This is going to save you a lot of time if you just know how to use that search box. The next one is about inserting objects. Okay, so sometimes you want to insert an object. Let's see here. Okay, object, and it's really just importing a program inside your interface. So for instance, I can import Excel, and I can type numbers here, and as you can see, the buttons here are Excel. So it's kind of like bringing in a program inside SolidWorks. So there's a lot of different ways you can use that. For instance, when we talked about design tables, that was one example where we had to use Excel inside SolidWorks. So this is an object. It's called an object inside the program. Select other. Okay, this one's one of my favorite ones. A lot of times when you're working with complicated objects, it's hard to select things that are behind other things. Like if I try to select that edge, you see, if I try to select this edge here, it's kind of hard to do that if I'm over here. So what you can do is you right click and you hit select other. You see, and you get some sort of x-ray, and with the select other you can really select anything you want behind the object. The next pointer you might want to know is recording video. So sometimes you may want to show someone what you're doing on the program, and you can record a little video of that. It's called record video, and then you just call it whatever you want. You can set the compression and frame rate, and then just say, okay, now it's recording. So it's recording what I'm doing, and then you hit stop when you're done, and what you get is this video. Let's take a look. See that? The next tip is keyboard shortcuts. That's in the customize, tools customize. You can bind a shortcut to anything you like. So one of the commands I really like is the repeat last command. So I set it to Y. You can change it to anything you want, and anytime you hit Y, it repeats the last command instead of retyping it, instead of finding it here. So it's a very neat tool. Design tree folders. You can add new folders to organize your tree. So over here you can add to new folder ABC. Alright, so you can really organize this any way you want and make this very clean. You can also add comments. Alright, so if you, let's say you're there we are, you can add comments. So let's say you're done for the day and you want to remember where you left off. So instead of just putting all these stickies, you can put some notes. Let's say fix interference issue on bracket, or need detailed drawing for this, need tolerancing, check better fit with washer. Okay, just like a little to-do list that you gotta do on your design, and you can save that, right? You can save this comment, and it's just really clean. Or maybe you want to leave some comments for the next person to take over, so that's a good way to store that information. The next one is tags. Tags are interesting. It's this little icon that you see here, and it's good for adding filters to your tree. So for instance, if I said printed, let's say I wanted to filter for 3D printed parts, it's not going to work because the only thing it's filtering for is the name. Okay, I can type a name and it's going to filter for that, but it's not going to filter for anything else. So if you want to filter for something specific, like something that's printed, you got to click that tag, hit printed, or whatever you want the keyword to be, and then you can hit enter or click out, and then when you hit printed, you see how it shows up? It's because I added a tag. I can do it again here. I can add another tag here. Okay. Now 2 items should show up, you see? So it's very cool. And if you want to delete it, you just click back here and just delete what you want. See, just delete it, and then it'll be gone. See? So, nice little filtering trick. The next tip is about feature properties, which is a hard-coded stamp, like an odometer. So anything you build, right? If you right click and hit feature properties, you'll see a hard-coded stamp for who designed it, who created that step, what time it was made, and then when it was last modified. So this is hard-coded. You can't change that, and it just gives you a little bit of a paper trail. It gives you a little bit of history of your model. Okay, so it's really good for reviewing history of SolidWorks assemblies. We are now going to move on to the next category, which is sketches, and the first one is snapping. So snapping is really just like AutoCAD. You see how when I draw I can snap to the midpoint. See how it's snapped? Or you can snap to the line or anything like that. So you can control all of that through the tools options, relations, and snaps. Just like AutoCAD, you can turn on these off any way you want. The next one is the numeric input. This is also kind of relating to AutoCAD. It's on the sketch. Enable on-screen numeric input. So this is more for people who are used to AutoCAD. So if you remember in AutoCAD, you kind of just type the number. Okay. In SolidWorks, you kind of just eyeball the line and then you put a dimension on it, okay, and then you refine it. That's kind of the default way. If you prefer the AutoCAD way where you just type a number and things like that, you can do that. But at the same time, you still gotta add your dimensions and you still have to kind of add your relations and clean this up. So there's still a little bit of that work. All right, equations. I already talked about that in other lectures, but again, this is a really powerful skill set. So you can just use it to relate dimensions together. And you do that by clicking the equal sign. With the equal sign, you initiate an equation. You select what you want to reference it to, and then you put whatever equation you want. So in this case, I'm putting times 2. When you do that, you get the sigma signal. Then you change this value, and as you can see, it updates that. So that's what an equation is, just like Excel. Alright, moving on. Now we're going to talk about the models and assemblies categories. The next tool is a simple hole tool. And it's really just a toned down version of the whole wizard tool. For instance, I've had situations where the whole wizard tool would just crash because there's just so much to it. So sometimes I would just use the simple hole tool to run a simple clearance hole like you see here. I mean, you could just use the extrude cut tool as well. But like I said, there's 600 buttons in this program. Not all of them are going to save you time. But this one might. Just because sometimes you don't want to run the whole wizard too many times on your tree and bloat your workflow. Okay, so there it is. The next button is the combine add subtract tool. And I already talked about that during the core and cavity exercise, but just to repeat, you can add and subtract models from each other, just like you see here. You can add or subtract it and it will connect. The next tool is the indent tool. And the best example that I can think of for this is what you see here. See how this plastic takes the shape of the battery? When I was modeling this cover, I really had no other choice than to use the indent tool. This was one of those rare situations where I really had no alternative. It works kind of like the form tool in sheet metal, only it's designed for solid modeling. And it works on, relatively thin geometries. It kind of punches out the shape. And the way it works is really like what you see here. You pick the target body, alright? Then you pick the tooling body. The body is going to punch out the surface. And you click OK and you get that. The next tool is called the deform tool. And it's a type of sculpting tool. For instance, what you do is you select certain nodes on the model and you can move it like this. You can move it with the translator here, or you can put in dimensions. But one thing you got to realize is that SolidWorks is not designed to be a sculpting tool. It's designed to be a very technical modeling tool where you type in numbers, very specific specifications, and hit OK, and it gives you the results. But A sculpting program would be more like what you see here. This is a model done in ZBrush, and ZBrush is just sculpting. It's really not very technical, where you kind of mesh the models, you sculpt them, you modify the vertices, okay? You modified each node, each edge by hand. There's not a lot of dimensioning in this, it's all visual. There are some programs that let you not only be technical, but also let you sculpt like this, like Katya. Katya is really a powerful 3D programming package that lets you not only do the technical side like SolidWorks, but also lets you do sculpting. But just understand that SolidWorks is not designed for that. That's not its bread and butter. For SolidWorks, it's just very technical, dimensional kind of 3D modeling. The next tool is the Flex tool, and I really like this tool, and I've used it quite a bit of times. But what it is, it's a way to deform an object. Let's say we want to twist this, okay? Watch what happens. When I add more angles to this, it's twisting it. So that's really useful. Let's say you're designing a propeller. A propeller is a really complicated object. It's not really easy to do that with just revolve and extrusions and things like that. But with the Flex tool, you can really achieve that easily. Or let's say you're designing an end mill. You're trying to cut the flutes out. You can just create a regular orthogonal structure and then twist it to achieve the effect that you want. Okay, so you can not only do twisting, you can do bending too, right? You can bend it, or you can taper it. Okay, just adding a little bit of draft, or stretch it. Okay, so you can really adjust and deform the model any way you like with the Flex tool. The D-feature tool is a way to consolidate your steps on your model. So you see, when you create a model, you have all these steps. The D-feature combines all of it into one feature that's called D-feature. And it's just a way to save memory and save space, and sometimes it's a little bit cleaner to work like that. So it consolidates, kind of like when you export to IGES or STL or something like that. This tip is about assemblies, control, drag, copy, and I've already discussed that during the assembly tutorial, but really all it is if you control, drag, you create a copy. So this is to save you time as opposed to re-importing, remating, and things like that. Oh, well, I mean, you still got to mate, but it just saves you time from re-importing and finding the location of that product or whatever. So we're now moving on to the next category, which is called evaluate. So this is about the analysis tools. First one is costing. Okay, costing is a nice tool to estimate how much it would cost to produce the model, to machine it, to weld it, to paint it, all of that. So traditionally, to get that cost, you'd have to get a quote. You have to send a drawing, maybe even the model and some schematics, and then you have to wait maybe a week or two, and you have to wait for the quote. And the reason it takes a while is because they don't want to underestimate the cost. Every quote is a bit of a gamble. No one really knows exactly how much it's going to cost to produce this product. They may decide to machine it and realize they ran out of fixtures here, or they realize they have a problem cutting this piece out and the cost goes up, or their machine broke down and things like that. So it's difficult to quote and it takes a while. So let's take a look at this tool. We have a cube with a counterbore hole inside, and let's see how much that would cost to build. So watch what happens here. You see how this is estimating how much it would cost, and this would change based on the material. As you can see, aluminum is a lot cheaper than some of these other metals. And you can customize this all you want. I mean, these numbers are not set in stone. You can even customize the cost of milling or drilling these features. Like, for instance, I can modify this. Okay, I can change this to whatever, and it's going to update my costing. You see? So it depends on the material that you pick. It depends on how complicated the object is. And once you set up your template, you know, this could be very powerful for you. You can really save a lot of time to optimize your designs so that they're cost effective. The next evaluate tool is about sustainability, which is an interesting way to see how much waste your product is going to produce. And it's right here, sustainability. So sometimes you want to know, okay, well, how much of a landfill waste is it going to produce? How much of carbon emissions are going to be produced when I manufacture this? How much pollution? How much water pollution? So you can pick the region, you can set some parameters on how it's designed, and get an idea of the footprint, right? So again, you got to think about this whole supply chain when you design. It's not just the CAD and then it's done. So do think a lot about that. Try to minimize the footprint as much as you can. The next evaluate tool is to measure, and this is something you really use every day. So again, it's in the evaluate tab and it's measure. You can use it to measure distances. So don't use, if you want to know this distance, don't go inside the sketch and use the dimension. Don't do that. Use the measure tool. And you can modify this any way you want. You can set the precision, you can set the units, you can do all of that. So this honestly is something you use so often. You can set distances to pretty much anything. See, there you go, 7.07 inches. The next tool is mass properties, and this is a good way to find the center of gravity, surface area, volume, and I think again it's right here. And I use that quite a bit. You can change the units here if you like, and I use the center of gravity quite a bit, especially when I'm trying to see where to locate hoists on a frame or on a machine so they can lift it with a crane. So I've used that a couple times. The curvature comb tool is kind of a way to get an idea if your surfaces are normal to the object. You get an idea of not only tangency but also if they're normal. In CGI, this is a little bit more of a relevant issue because sometimes your surfaces will flip upside down and it glitches out. And you would use the curvature combs to make sure everything's clean and in the right direction. So it's a way to kind of optimize or visualize your surfaces in a little bit more detail. The statistics option evaluate button is to kind of show you how long it takes to perform certain tasks. So as you can see, to load, the circle pattern tool took the longest amount of time. So sometimes you use that to optimize. You say, all right, to make my workflow go faster, let me instead use a texture JPEG to show my perforated mesh as opposed to creating a pattern. And then you'll see it run a little faster. So again, this is a little bit more relevant when the computers were a little bit slower. Nowadays, it may not be so essential, but again, it really depends on how complicated your machine is. The next button here is the center of mass. This is just another way to see the center of mass dynamically instead of using the mass properties tool or the measuring tool. You kind of see it permanently on your model, which may be helpful for your design. The next category is editing. So this is when you're kind of troubleshooting your model and you want to make fixes easily. So let's talk about some of these. The first one is to rebuild your sketches. So this is the rebuild button. It's right here. Anytime you change something, you can hit this rebuild button to change it. But what I'm trying to say is if you want to modify, you don't necessarily have to go inside the sketch. You can modify it right here. Just hit the rebuild button and it's going to update. So maybe that saves you a couple clicks to troubleshoot and modify your model. The next pointer is to edit sketch plane. So let's say we created a sketch on this plane here and we created it on the top plane, we want to create it on the front plane. But we don't want to delete and start over. So you can right click the sketch and hit edit sketch plane and then change it to another plane. And what happens is it rebuilds. You're not going to always get so lucky. A lot of times you'll get errors and it's going to glitch out. But if your model is simple enough, you can easily switch to plane and avoid having to start over. Next button is suppress and unsuppress. This is good for troubleshooting. A lot of times you want to see how this model was built. Maybe you have some errors and you want to diagnose it. You can move this line here, and when you move it, it lets you go back in time. Okay, it lets you go back in time to the very beginning, so you can see how it was built. Or you can suppress manually. You just right click and hit suppress and unsuppress. Or you can hide it. Hide it is just displaying it hidden, but it's still there. Suppressing is pretending like it's not there, meaning the mates are going to get all messed up, the explosion views are going to get updated, and it actually almost removes it. But hiding just hides it from the tree. So anyway, sometimes it's good to suppress and unsuppress because it will help you troubleshoot the errors. Another good way to troubleshoot errors is to look at the parent-child relationship. If you right-click and hit parent-child, it tells you who the parents are and who the children are. For example, this counterbore is a child of this because it is dependent on this surface. Meaning if I delete this cube, this counterbore is also going to get deleted because this is dependent on that. And you can even see with those arrows. You see those arrows? It tells you what it's dependent on. And you can see that dependency with the parent-child relationship. As you can see, the counterbore is a child of the boss. So you can do that to help diagnose. The next tool I really like is the Find References button. A lot of times in SolidWorks you open a file and you see it's blank. It's because it's lost the reference. The link was broken to the location of the model. So sometimes you have to reconnect that link by finding references. Or sometimes when you open a drawing, right? If you open a drawing, you can also click references here to reconnect that location. Okay, so just an FYI, sometimes you do have to do that. Okay, 2 more tips. The replace component tool is useful on an assembly. On the design tree, sometimes you want to replace bolts with another bolt, and you don't want to reinsert every bolt and things like that. So on the design tree, okay, which is here, this is not an assembly, but on an assembly you right click and you will see a button called replace components. Okay, if the new part is similar enough, you will get a pretty seamless transition. Okay, you will get a pretty seamless update with the new hardware. If there's a lot of differences between the two models, you'll get a lot of errors, and it may not even be worth to run this replace components. But sometimes I've had situations where I've had this huge array of bolts and I wanted to replace all of them just because the bolt was just an inch longer or something like that. I didn't want to do all that work again, so I just hit replace component and that whole area of bolts would instantly be replaced, and that was a huge help for me. Finally, the last tip that I have is the pack and go. It's kind of like the defeature button. It's very similar to that, and the idea is to kind of consolidate all the files into one location. So a lot of times when you design, you insert parts, you remove parts, you optimize. But over time you get a lot of garbage that sits there, a lot of dead parts that you didn't even end up using. So a pack and go is kind of a nice way to extract the latest and greatest, the latest design, put it in a folder where it keeps all the parts that you used and all the references are in one place, and this way you can use that location for the latest and greatest submission. And if you want to go even a step above that, you can even make virtual. You can even make all the parts inside that final assembly make virtual, so then you get one file, not even an array of files in one folder. You get one file that contains all the parts together, and you can send that as one entity, and that's how you would consolidate the final product. I personally don't encourage making virtual because a lot of times you use certain parts for other assemblies, and it's just not a clean way to work. So making virtual is really for exceptional cases. In a real design workflow, you want to definitely have separate parts that are referenced to different assembly files. Okay, but anyways, that's what the pack and go is. It's just a nice way to consolidate your final assembly with the latest parts. So that concludes some of the pointers on miscellaneous tools, and I encourage you to take advantage of some of these because it might save you some time.